Rewrite the quadratic function in standard form and give the vertex. So this particular function, in order to rewrite it in standard form, what we would need to do is express it as a perfect squared trinomial. So this would be a times the quantity x minus h squared plus k. Now to get it in this form, what we have to do is complete the square. Now, in order to do that, what we will do is start off by separating any terms that have an x away from the constant term. If there happens to be any coefficients on our x squared term, we need to factor that out. So I'll factor out of this group a 2, which leaves me x squared plus 4x. And then I'm going to leave a little bit of space before my plus 9. Now, to complete the square, we take the value that is multiplying x. We divide it by 2, so 4 divided by 2, and then we square it. So this would be 4 over 2 is 2, squared is 4. So I'm going to add 4 right here, but I have to keep the equation balanced. I can't just add 4 here and make everything balanced. In order to balance it out, what I have to do, and this is kind of surprising, but I'll show you in a second why, I have to subtract 8. And the reason is, when I'm adding 4 inside these parentheses, I'm not just adding 4 to this side of the equation. I'm actually adding 8 because 2 multiplies everything inside that set of parentheses. And that's the trickiest part of this whole process. Once you get that down, the nice thing about the next step is this perfect squared trinomial, it always factors in the same way. So when you have x squared plus bx plus this special term, b over 2 quantity squared, it factors into x plus b quantity squared. Oh, x plus b over 2 quantity squared. So all we need to do is just take half of this number, so x plus 2 quantity squared, and then I have 9 minus 8, which is 1 on the outside. So my vertex now, the vertex I get just from the coordinates h and k. So the only thing you have to be careful of is the h has a negative in front of it. So from the original problem, you have to make sure you take the opposite of that value. So this would be -2, 1 is the location of this vertex.